So I have this Fluke 2640 NetDAQ data acquisition unit. It includes a 5.5 digit DMM and a scanner multiplexer. I want to dump the flash from this chip right here, which even if I desoldered, I don't have the socket for this. So I'm going to do a partially non-invasive ROM dump, and it's tedious to say the least. And I don't do it very often, so I'm doing this sort of as a reminder and for anybody else who needs to do this. The annoying thing is that it's not really, it shouldn't be necessary to do this, but I'm not aware of anybody else having dumped these. I haven't found any evidence of Fluke providing firmware updates. They mentioned it in their documents, so I know it's possible over the serial connection on the back panel. It also mentions a debug connection here, which isn't populated, and there's also, it's kind of the same thing on the ADC board on the other side, but it's not documented, and yeah, chicken and egg. When I see the firmware, I can probably figure out how to do it from the normal serial port. And the idea is to use these squids, hook them up to the address and data bus and a couple control signals. Then I'm going to park it over here and hook it up to the logic analyzer, because these cables are not particularly long, and I'm going to have to script this process because these older ones, they have a limited memory depth and there's no way I can capture the entire flash. Okay, that was fun. The key to doing this, well, there's two things. I've done this a few times and found what really helps to tie your pods to somewhere, or tape or whatever, because if you knock these over, then the clips start popping off and then you have to start over. And the other is when you're probing like this IC there's a lot of clips down there, and it pays to plan ahead and start installing the clips that are in the middle of a row, and also to install those that go underneath or to another chip. I didn't completely succeed in doing this planning, so I had to sneak a few of them on actually the wrong chip. And also, thank goodness for these little extensions. I had a few of these. I think it's the first time I really need them, because I was running wires from this end and then I realized I had to sneak one right over here to this other IC. Alright, so I'm almost ready to start. I got the DAQ sitting on top there. I thought of something for that, and about that need to reset this every time I fill up the memory. Well, I just thought there's an undocumented command that triggers a self-test, and I'm almost certain that that includes the ROM checksum, and I can trigger that over the Ethernet connection. Okay, I'm recording this for the second time because now I know what I'm doing, and I wasted a lot of time trying to get the inverse assembler to work, which is a partial failure, so I'm going to keep that for a second part. I'm going to go over the machine setup a second time because I think that's interesting. On these, there's two machines, and for dumping a ROM, you really don't need the second analyzer here. You can assign these pods to whatever machine you want, so I'm going to need these. The first thing I want to do is validate that the timing is good and that the clock that I plan to use is appropriate. This is fine. I don't need 500 megahertz, although I don't need it, but I want it because I want to validate setup and hold times. I'm going to create a quick label for address, data, and I'm going to call this status. I just want a couple control lines in there. And I'm going to Okay, that's fine, and I have a couple of addresses on, well, you see the arrows, because I have the Fluke DAQ running just beside it, so this tells me that there's some action there. And for this I actually prefer using this input because I can scroll. Okay, this last address bit is the chip enable of the flash chip, and I'm using that to make sure that I'm in the right address space. These three are the upper byte and lower byte select. I'm going to throw these into, oops, said, so I want the last three like this. So I have this set up. Next I'm going to go into the trigger. This is a very basic trigger. There's nothing special. As soon as I press run or as I click run up here, it's going to start and record everything. So I can go into listing and press run, and there we go. This is not a very interesting view for timing. I like to go into waveform, and then I tweak this display. Oh, I forgot something. I gotta go back to format. I want to look at one of the clocks, because at this high speed it's using the half channels, which doesn't include the P clock. So I'm gonna go with full channels. Yeah, there we go. So here's a clock P, and I'm going to call that, it's called address. The delete key doesn't work as you would think. Okay, so I want the P clock here. Okay, go for another run. Okay, then there we go. So I definitely want a S, so that's this is the clock that I'm going to be using for state analysis, and I want to see if, I think if I do this, it packs them all onto, yeah, all onto the screen. Now the cursors are absolutely weird here compared to the usual oscilloscope. So that works is to go into markers, and you want time, and then you're going to have a couple of markers here. The T is your trigger point, and you can shift the move left, shift the screen left and right with this, and it's pretty slow. It helps to zoom out with the seconds per div. So let's say I want to look at this edge right here. This is about right. I'm going to zoom in a bit. So I'm trying to look at this positive edge on the address select. I mean, I pretty much see what I need to see already, but right, so I can see that the addresses are valid when the address select is low, and once it rises, then all bets are off. Like, I'm gonna look at data next. Go back to format. Okay, it's off for some reason. Data was on pod A8. Okay. Oops. Okay, so if I do clear entry, it toggles everything. That's good to know. So I should have data now. I can write another capture. I'm going to look at data. I want, okay, that's sequential. Right, so if I use the falling edge of address select, then the data is not valid yet. Pretty sure this is a flash access. So this is the TAS, or, well, I don't remember what the symbol is, but data is valid during the rising edge. Okay, so I know what clock to use, I know that the timing works, so I can change this machine type to state, and then I can go back to format here, make sure my stuff is good. Yeah, I can use full channels, it doesn't matter. Master clock, the way this works is well explained in the manual. It combines each of the edges are ORed together, like if you wanted to save on rising edge on J and L. Which is not the case for me. I just want the P clock on the rising edge. Qualifiers are things that you can configure to enable. Let's say I want, right, there you go. So you want J equals to 1 and nothing, or a positive edge. You can do some pretty sophisticated stuff. Here I think, like for this I need to check the manual again, but I think this is what I want. I want a setup time to make sure that I sample the data just before the edge. Okay, then I'm going to Alright, this is good. You can't really move stuff around other than clicking on the one just before, then you press insert data. I just like to have address and data next to each other. I don't need this one. Something interesting to look at. Also, I'm going to present it now, but it's going to be useful a bit later. I'm looking at the listing here, and you can graph the addresses. Well, you can graph everything. So instead of the waveform, I'm going to go in a chart. And let's say I want to look at a 256 byte chunk from 370 to, yeah, something like that. And you can see these lines, that's the code path. It's doing this short loop. This is going to be useful when I'm looking for the checksum loop. To find the checksum loop, I'm going to be using the trigger configuration, which can get pretty complicated. And it is in the manual, but you still need to mess around with it because it's not all obvious. I'm going to try a simple trigger first. I'm going to call that reset vector. And this term is going to be true if the address is 0, and I don't care about the others. It did set CE0 because that CE bit is also, I mapped it to the address as well. Here, ROM control, you only need that if you need to use the external BNC connector. Acquisition control, I think when you do this it just saves everything. You can go to sort of an oscilloscope with pre-trigger, and I will need that a bit later, not now. I'll just leave that on automatic for now. I'm going to run, and it's waiting for the first trigger, so I have to cycle the power on the DAQ. Off, on. Okay, it triggered. Well, I'll get back to this chart. Go to the listing first. And it did a pre-trigger, so it was running this same loop I was looking at, and then reset. Oh, it kind of makes sense. I see 4B6 and then it's jumping here, so okay, that's a good reset vector. I looked at this earlier. I was hoping to see a ROM checking loop. I was hoping to recognize something increasing because it would cycle through all the addresses, all the while running the same code from the same area. But I zoomed from X to 4000, and it's waiting for something. Oh, hold on. Alright, so the reset vector is down here, then it jumps there, it does something, then it jumps who knows where. So it's not what I'm looking for. So I go back to trigger. I'm going to leave that there because it's kind of useful. I'm going to create another one and checksum test. My first mistake was I figured this address in ROM is most likely not used very often and probably used in a checksum loop. So I messed with that and I played around with trigger settings, but I forgot it's a 16-bit data bus, so you're not going to see odd addresses. But if I do this and replace this condition with this new term, then I can run again, and it needs another power cycle. Okay, let's see the listing here, and what do I see? So I see this was a trigger point. It read the FFF0, then read FFF2. I can scroll down. So this is pretty much what I would expect from a checksum loop. It's reading a memory, running a short loop of code, increasing the pointer. I don't see it on this scale for some reason, possibly because I'm zoomed out way too much. Well, first of all, this is way off. Okay, so I see kind of what I'm looking for. I see this slope rising. I'm fairly confident this is a checksum because it's also fetch. Oh, that's interesting. I didn't notice. So these fetches, the ones that are incrementing, are in the flash address space, but it looks like it's running from RAM for some reason. Okay. What I'm going to do now is I'm wasting a lot of memory depth by storing all these accesses. So what I want to do is set up the triggers to trigger on, let's say, 82 EBA, and only save the next access. By default, in acquisition control, in automatic, it stores state on every state change. So you want manual, and you want to not store the branches. So on the first level, it doesn't store anything. If I trigger the checksum loop, then it should pass to this step, and then it should store the state and store nothing. And on all states, I wanted to go back to step 1. Okay, I don't know if that's gonna work. Obviously I'm recording just always the same opcode because it was running in a loop. So I'm going to edit this trigger again, and I'm going to try it with a reset. So I need this. So this was part of the checksum loop. I'm going to go back here, and start a capture, so it's waiting for the clock, power up. Alright, so for some reason it's starting that loop, that particular loop at 8000. Let's check the waveform from 0 to... Well, you know, at least it's kind of in the right ballpark. And it's looping. Alright. So this is usable, because in this listing I have raw data and addresses, and I'm maximizing the use of the sample memory, so I can script this. So what I suggest doing at this point is to go into system and go make a copy of this whole setup, so that if you power it off or if you mess up something, you can keep going where you were at. So I'm going to save all the settings. I'm going to call that... Thankfully it lets you enter a 32 character description, so 82 EBA. Okay, I'm going to save this. I'm still playing with the triggers to get ready for automating this. It's never as simple as one would like. Now here's what my trigger setup looks like. The idea here is that I had to add a few steps, because once I start dumping, then I'm going to want to skip some hits. For instance, the checksum loop I identified at 82 EBA. The first time, if I run with a simple trigger I had earlier, then it worked fine. It's going to capture 8,000 hits. On my next iteration, I'm going to have to do something fancy, and this is what I have. So initially, when I press run, it's going to wait for that first hit of that loop opcode while storing nothing. Then it's going to test the address. And now, just for a quick test, I set to 8060. This value would be incremented automatically on every run. Step 3, still storing nothing. Then it looks for another opcode, another hit of that 82 EBA. This is going to be the main capture loop. See, I got the arrow going on here. So if I don't detect the loop opcode, then it loops back to level 3. I store, that's basically what I had earlier, and I think this works now. If I run, force a reset manually, takes a few seconds. Okay, I'm way at the end of that trigger. Let me just go back up. I see it started the capture at 8062, and those are all my memory reads, so this is working fine. Okay, what a marathon. I think maybe I got it this time. I had to do some minor tweaks on the trigger setup here, especially for storage. And of course I had forgotten to set the trigger position to start. And this right here, this step was causing problems I had while storing no state in here. But when I did that, I was missing the first hit in my listing, so I had to change that. And obviously any state doesn't work because you end up with spurious data all over the place. So I think this is good now. Let's go to the listing. And the code's going to be on my GitHub repo. I tried to make it generic. It might work with a bunch of HP logic analyzer with maybe some minor modifications. I'm going to dump 128 kilobytes, so I fire this up, and then you see it's waiting for me to reset the target because I was not able to automate this. Okay, got the data. You see it parsed the capture, and it's asking me to be a button pressing monkey. And I see the listing updated. I got the next chunk. Alright, well that's pretty easy. It's really too bad about the automation. I tried hard, but this is fine. It's gonna take me a fraction of the time that I spent working on the script, so good deal.